Okay, this week we are dealing with a two-way between groups ANOVA. And what's different about a two-way between groups ANOVA is that now you have two categorical factors. In this example, I'm going to use year in school and gender. Whereas last week you only had one categorical factor, and that was a one-way ANOVA. For both of these types of ANOVAs, you do have a continuous dependent measure. In this case, what we're predicting is week 1 grades. And so what we're going to look at is the relationship between week 1 grades and year in school? Or is there a relationship between week 1 grades and gender? Or do these variables interact such that there's a relationship between year in school and gender that varies with respect to week 1 grades? So we'll have three sets of hypotheses, but our research question would be, did year in school and gender impact week 1 grades? Again, last week we dealt with just one independent variable, which was age group. So you will be adding in a second independent variable and looking at the relationship between those two variables and your dependent variable. Okay, so what are our hypotheses? As I mentioned, we're going to examine two factors as well as the interaction. So for the first factor, year in school, our null hypothesis is that year in school will have no significant effect on week 1 grades. Remember that with our null hypothesis, we're proposing or we're theorizing that the means are equal. So first year grades are equal to second year grades, are equal to third year grades, and equal to fourth year grades. Our alternative hypothesis is that year in school does have a significant effect on week 1 grades. So first year week 1 grades are not the same as second year week 1 grades, and not the same as third year week 1 grades, and not the same as fourth year week 1 grades. Next, our next factor is gender. So in this case, our null hypothesis is that gender will have no significant effect on week 1 grades. In other words, male grades in the first week are equal to or the same as female grades in the first week. Our alternative hypothesis is that gender does have a significant effect on week 1 grades. So male grades will not be equal to female grades in the first week. And then our third set of hypotheses have to deal with the interaction. Our null hypothesis again is that these means are equal, so that the interaction between gender and year in school does not have a significant effect on week 1 grades. If we write that out, it would be male first year grades are the same as female first year grades, are the same as male second year grades, are the same as female second year grades, and so on. Whereas our alternative hypothesis is that the interaction between gender and year in school does have a significant effect on week 1 grades. So those are our research questions and hypotheses. So let's see how we would carry this out in SPSS. We're going to go to our data set. As I mentioned, we have three variables. Year in school, where we have 4 categories. Gender, where we have 2 categories. And week 1 grades, which is a continuous variable. So we can see that here, these are the variables we're dealing with. So what are we going to do? We're going to go to General Linear Model, Univariate, and we're going to put our dependent or continuous variable into the dependent variable box, which is week 1 grades. And we want to know if week 1 grades vary by year in school and by gender. So when we go to options, we're going to click on descriptive statistics so we can see the means. When you're dealing with your master's or dissertation, you'd also want to look at your effect size and homogeneity test, but we're going to keep it simple for this analysis. And then we're also going to do plots, because when you have an interaction, it's really important to look at your plots. So we're going to do the variable with the most categories on the horizontal axis, and since year in school has 4 categories, we'll put that here. Gender only has 2 categories, so we'll put that in the separate lines box. And then click Add and Continue. So now we're ready to run our analysis, so click OK. So at the top, you get the number of participants in each group, followed by a box with the means, which are of course important because that's what we're looking at, is there a significant difference between the means for each group. And the test of between subjects effects tells you whether these means are in fact different. So we're going to look at each main effect. The first one is year in school, and we see that the F value is 1.822 and the significance is 0.158. So because that is greater than 0.05, that is not significant. So when we write that up, we would say there is not a main effect. Move this up so it's easier to see. There was not a main effect for year in school. Our F value, degrees of freedom, were 3, and our error is 42. So it would be 3, 42. And the F value is 1.822. P equals 0.158. So first year grades and second year grades and third year grades and fourth year grades did not differ significantly from each other. Now let's look at our next main effect, which is gender. If we look along this line, we'll see that the mean square and the F value are in fact much bigger, and we do have significance at the 0.001 level. So there was a significant gender difference for week 1 grades. F 1 and 42. So we took the degrees of freedom here as 1, and then you take the error for your denominator, degrees of freedom, 1 and 42. F equals 14.185. And P less than 0.01. It says 0.001, but we have to say what it's less than. So it's P less than 0.01. Now when there's a significant difference, you should also include the means so that we understand what this difference is. So what was the difference between males and females? And we can see here that the average for males was 71.42 and for females was 82.75. So females had higher week 1 grades than males. And again, we would write the N is 24, mean equals 82.75, standard deviation equals 8.941. And then you would do the same thing with males. Okay, so we took the numbers from these rows right here, and if you scroll up a little higher, you'll see that that was in fact the mean, standard deviation, and ends that we're looking at. Okay, finally, let's go look at the interaction. Is there an interaction between year in school and gender? If we scroll over here, we'll see that no, the F value is very small, 0.455, and the significance is 0.715. And in fact, if you look at the plot, you'll see that the lines are roughly parallel to each other and they don't intersect. So there's not a significant interaction between gender, and you're in school. So we're going to write there was not with respect to week 1 grades. And our F is degrees of freedom are 3 and 42 equals 0.455, and P, our significance value is 0.715. So that is what you need to do for a two-way ANOVA.